Hello everyone, welcome to the solutions for B.Stat and BMath entrance 2024 for ISI. We are looking into all of the solutions, right? So we have done a few earlier and now we are looking into the remaining questions. So this is question 3 and here the question says, the question looks a bit complicated, right? It says Sn be the set of all n digit numbers whose digits are all 1 or 2 and there are no consecutive 2's. Okay, so 122 3 digit नहीं हो सकता. Alright, 1122 cannot be a 4 digit number and so on. Alright, so for a single digit number you would have only 1 or 2, right? There is no scope for repetition. So this is how we will be constructing the sequence, and this question is from number theory, and I can tell you that when I solve this question you will enjoy it. Alright, so let me show you how this is done. So basically here we will be looking into S1 first. Alright, so S1 will be what? 1 and 2. I cannot have anything more than that, right? So what about S2? S2 I can have 11, 21 and 12, right? So 3 elements, right? Here I have 2 elements. Alright, 2, 3. And now let us check about any nth element of any Sn. Alright, so let us denote that by Kn. Alright, so how would Kn look like? Now for Kn it only consists of ones or twos, right? So Kn can look like either 1 starting with 1 and then dot 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 n minus 1 digits, right? We have considered that Kn is a valid member of Sn. Alright, so then the consecutive rules of 2's are followed. Okay, then here are 2. It can either start with 1 or it can either start with 2. Then there will be n minus 1 digits here. But how do they look like, right? So when we start with Kn, once we have fixed 1, then what about the other digits? The other digits will be similar to the construction in K of n minus 1 set, right? That is fixed for us because we cannot change that. Alright, now once we have that, we move on to the second option, K2, right? So sorry, Kn that begins with 2. Now if Kn begins with 2, then we have an immediate restriction there. We cannot place 2, right? Because they have that order of no consecutive 2's. So once that restriction is placed, then here I have only one option. So even if I multiply it by 1, then my total number of permutations remain the same, right? So I would be ignoring this. Other than this, how many options are there? N minus 2, right? So if I have 2 at the front, then I can only place 1, and after that 1 I would be following this logic, right? So I have Kn minus 2 set similarity in this bracket. Alright, so for 1 the other positions will be arranged according to Kn minus 1. For 2 I'll have 1 after it, and then all the other positions will be arranged in Kn minus 2 ways. So how many ways of arranging Kn? That will be basically Kn equal to Kn minus 1 plus Kn minus 2, right? Now you know this sequence, right? If I I have already told the name, I think this is the Fibonacci sequence, right? In which the sum of the previous terms is equal to the present term. Alright, so n minus 1 and n minus 2. That means if I am on the third term, I'll add the first and second term. Okay, so first and second term we already calculated here, right? First term was 2 and second term was 3. So how would you construct the sequence? That would be 2, 3. Sorry, this is too light. So I would go at K1 that was 2, K2 that was 3. So I would construct K3 as 2 plus 3, right? 5. Similarly, K4 would be 8, K5 would be 13, right? I'm just adding the previous two, right? K6 would be 21, K7 would be 44, no, 34, right? K8 that would be 55, K9 would be 87, right? And no, sorry, 89. and then I would have K10 that is equal to 144, right? Now check the options. I would have to find 10th term, right? 10th term, number of elements. There are 144 ways in which we can arrange the ones or twos, so there will be 144 unique elements. That is option C. Alright, now this sum was solved by allusion to the Fibonacci sequence. Now this is a chapter that you will find in a bit advanced textbooks. This is known as recurrence relation. Alright, these questions occur very rarely. I think I have seen like 1 or 2 questions from this in the last few years, but this is very rare. Alright, so some questions will be there in an exam where the solutions will be a bit rare, bit unused. So when we prepare for these exams, sometimes we strategically decide to skip these, because if there is a low probability of occurring, why would we do it? But even if you have not studied that particular chapter, if you know about the Fibonacci sequence, you can find it appearing everywhere, right? So this question is a direct application of that. You could relate it to Fibonacci sequence, and without mentioning the chapter of recurrence relations, I could have done it, right? Just as I did. I only mentioned about the recurring relations towards the end. So once you construct that, once you know that we have a general term Kn in Sn known as either starting with 1 or starting with 2, because those are the only two options. Okay, so if it starts with 1, then the other digits can be filled in Kn minus 1 ways, right? Because Kn minus 1 will be in Sn minus 1, right? So all the rules of the previous set will also apply there. If it starts with 2, then there is one restriction. I cannot place 2 after 2, because that is the rule, no consecutive 2s. So I'll have to place 1, and then as soon as I place 1, the other n minus 2 digits will follow the rules of Kn minus 2 placement, right? So Kn equal to Kn minus 1 plus Kn minus 2, again Fibonacci sequence, done. Alright, so I'll be looking into other questions after this. If you have any doubts, queries relating to this course or questions, because many exams are coming up soon, you should contact the numbers given below and we'll help you there. Alright, so bye for this one.